Hello lovelies, in this video we're going to be going through binomial distribution for your A-level maths. Now there are lots and lots of parts you need to pay attention to in this, but we're going to take you through all the questions really slowly so you don't get confused.
The first question says that given that x and then we've got a squiggly line and then b, and then we have some numbers. So what does this mean? This means that x follows a binomial distribution. So now that you know it's a binomial distribution, you're given some numbers, we can look up the value. So we've got 12 and we've got 0.25. So let's look at where these numbers come from. So the 12, that refers to the number of the table you're looking at. So I've pasted table 12 onto the screen here. Now you might have a formal booklet that's full of these, so you're going to look through and find the correct table. Or it might be you can put these values into your calculator. And if your calculator can do binomial distribution, then you can look at the manual for it and look up where binomial distribution is and see what the commands are. But I'll be using the table for this video. Once we've got the correct table, we need to know which column in the table we're looking at. So the next number, 0.25, refers to the column in the table. So this is the probability we're looking at. So the probability is 0.25. Next, we need to know the correct row. Now, we're trying to find the probability that x is less than or equal to 1. So if it's less than or equal to 1, then the row we're looking for is row 1. If it's less than or equal to, really want everything below 1, so the 0 will count as well. But what you'll find with these numbers, if you look at the table, it's cumulative frequency. So each number includes the numbers above it. So when we have our x equals 1, and we can see that it corresponds to 0.25 at 0.1584, we don't need to add the value above to it, because the 0.0317, that's already been added onto this. It's already included. It's cumulative frequency. And you can tell it's cumulative because at the end of the table, you've got a value of 1, which is telling you that's kind of, for probability, that's the maximum probability you can get, isn't it? 100% chance. So to recap, 0.25 is telling you the correct column to look at. The less than or equal to 1 is telling you the correct row to look at. And the 12 is telling you the correct table to look at. And you need to remember which one's which. However, the 12 is a whole number. The 0.25 is a decimal. It's always going to be a decimal. And then the x is less than or equal to 1. You can see that x is next to that number. So it should be pretty obvious which ones are which. And that's it for this question. So we can just write that the probability of x being less than or equal to 1 is 0.1584. Now, before we move on, let's talk a little bit about what this actually means. So imagine that we are flipping a coin. And let's say it's a biased coin. I'm going to flip this coin 12 times. So that's where the 12 comes from. We could call this the number of coin flips. It doesn't have to be coin flips, it could be other things, but it's going to be a probability where it's going to either happen or it's not going to happen. Then we've got the 0.25. So that is the probability of what we're looking for. So for example, this could be the probability of getting heads. And now normally it's a 50-50 on a coin, so that means this will be a biased coin. Now the last thing is the x is less than or equal to 1. So this is going to be the number of successes. So this would say we're going to flip a coin 12 times. The probability of getting the side of the coin that we want is 0.25. And we want less than or equal to 1 of the thing that we want. So let's say we want heads. We'll say we want less than or equal to 1 heads. So the probability of flipping the coin once and getting a head is 0.25. However, we're flipping the coin 12 different times. And so what the probability shows us is getting less than or equal to each number in the 12 flips. So while you had a single flip is a 0.25 chance, if you do 12 flips, because you've flipped so many coins, you've actually got now a 0.1584 chance of getting 1 or less. Because more than likely, you're going to get more than 1. So it's not going to be a 0.25 chance, it might be lower. You'll see as you get towards the end of the table, you approach 1. So your chance of getting 11 or less heads is almost approaching 1. Now that might seem a bit odd to you. What about x equals 12? Why isn't that on the grid? Well, if you think about it, x equals 12, getting 12 or less heads, that includes every possible outcome, because it's including 0 heads, it's including 12 heads and everything in between. So of course that's going to be a 1. But why does it look like that 11 and 10 and 9 and even 8 is really close to 1? Why are these so close? Well, it's all about the possibility, the probability of getting 11 heads in a row is so tiny that it actually shows up as a rounding error. So when you round it to 4 decimal places like here, it comes out as 1. It would really be 0.999999, something that'd be really, really, a really high chance. So just be careful of things like that. For our next question, we've got x follows a binomial distribution. So you look at your binomial distribution tables. We have a 10, so we're looking at table 10, and we have a 0.35. So we're looking at the column for 0.35. Now for this question, we're looking for when x is less than or equal to 3. So we find x equals 3. So less than or equal to 3 is that number and everything below it. So the 2, the 1, and the 0. With cross-reference on the table, we only need the x equals 3 and the 0.35 intersection, which is here. We don't need the ones above it because they're already baked into this number. X equals 2, 1, and 0 is already included in 0.5138. And that is going to be our final answer. So the probability of x being less than or equal to 3 is equal to 0.5138. You can times it by 100 and get a percentage. It'll be around about 51% chance. For the next question, so we want part 5 of the table, a fifth table, so n is equal to 5. We want for the probability, p, 0.4. That tells us the column that we're looking at. And you can see it says p at the side of it. And then we want x is going to be greater than or equal to 4. So look at the table. Well, 4 is greater than or equal to 4. It's equal to 4. But there's nothing greater than. So that's one that we're looking at. And when we look at where these two places overlap, it's going to be 0.9898. So what we found, we're very, very careful here, the probability of x being less than or equal to 4 is a 0.9898. So a really important thing here is all these x values is cumulative frequency for less than or equal to. So if we want to find more than, this isn't actually the right answer. We want to find x is greater than or equal to 4, not less than or equal to 4. So what do we do in this situation? Well, we're going to look at the diagram, and what we're going to do is we'll look at things that are not greater than or equal to 4. So 3 isn't greater than or equal to 4, and 2 isn't, and 1 isn't, and 0 isn't. So these are the numbers that we're looking at. And it's relative frequencies. We don't need to look at 0, 1, and 2. We just need to look at 3. So what we do is we look at what's not the thing we're looking for. So we can say that the probability of x being less than or equal to 3, which is all the numbers that aren't greater than or equal to 4, is 0.9130. So then we want the probability of x being greater than or equal to 4. These are mutually exclusive, and they're going to add up to give us 1. So all we need to do now is get 1 and take away 0.9130. And that gives us 0.087. And if you did normal distribution first, this kind of thing is going to be familiar. Because basically, to save time, the tables only have less than or equal to. So if you want more than or equal to, then you do the kind of opposite calculation and take it away from 1 to get what you need. You'll also notice that the probabilities only go up to 0.5. So your probabilities are more than 0.5. Again, this is going to be symmetrical, and what you're going to do is find the probability of what you don't want and then take it away from 1. So it's just methods of kind of reusing the tables and making them shorter, because if we had both of those things in here, then the table would be 4 times bigger. So it's just a thing to save space. I should also mention that this x is greater than or equal to 4 is 0.0870. If you multiply that by 100, that's nearly 9%. So it's a very, very small chance. When you think about it in terms of coin flips, it's a 0.4 chance of what you want, which is pretty close to a half chance, like a normal coin. So you think, what is the chances of getting the same thing 4 times in a row? And it's very, very likely you're going to flip a coin and get the same thing on the coin 4 times in a row, especially the probability is a little bit less than half. So again, you can think about your answer at the end, and these should make sense, especially at the extremes like this, which could be a very, very small chance. So let's try another example like that. So n is equal to 25. Again, the first number is n. P is equal to 0.25. So the second number in the brackets is P, the probability. So again, think about coin flips, number of coin flips, the probability of getting the side of the coin that you want, or other bits of probability that have a kind of a yes or no answer for you getting what you want or you're not getting what you want. And then we've got the probability of x is less than 6. So what we're going to do is we're going to highlight every number that's less than 6. That'd be 5, 4, 3, 2, 1, and 0. You'll notice I haven't highlighted 6 itself because 6 isn't less than 6. So when cross-referencing my numbers, what I need to be looking at is the x equals 5 number. And so what I'm saying is the probability of x being less than 6 is equal to 0.3783. That's the same as the probability of x being less than or equal to 5. So you be really, really careful if you've got a less than or a less than equal to, because it's going to involve looking at completely different cells in the table. If it was less than or equal to 6, it'd be the number below it, which is 0.5611, which is significantly bigger. So again, we pay really, really close attention to less than and more than signs, and if they have an equal involved. For our next example, so we're going to look at n is equal to 9. We're going to have a look at the probability being 0.35, and we want x is greater than or equal to 5. So let's highlight all the places where x is greater than 5. So we've got the 6, the 7, and the 8. There's actually no equal than there, so we're not going to include 5 itself. Now, we know that the table is cumulative, and it's always less than or equal to, so we can't look up the values for this. However, what we can do is we can look up the values for everything that it's not, and that's the x equals 5 all the way down to the x equals 0. Now, these do all go all the way to the bottom. These are less than ones, so it's only going to work with less than. So what we can do is look in the correct column, and we've got the 0.9464. Again, look at the biggest number in the column, because this includes the x equals 4 and 3 and 2 and 1 and 0. So we can say that the probability of x being less than or equal to 5, which is exactly what we don't want, is 0.9464. So if we want the other bit of this, x is greater than 5, these two probabilities are going to add up to make 1, because if you look at the highlighting, they include every single row. Some of the rows are purple, some are blue, but I have included all the rows in this. So do 1 take away 0.9464, and that gives us 0.0536. So again, if you get a greater than, you can't look up greater than from the table, so you look up the less than that includes all the other values, and then take that away from 1 to get your greater than side. Our next question, n is equal to 6, and our probability is 0.35. And we are looking for x is equal to 2. So for this one, we only want x equal to 2. We don't want anything else. The previous questions have all been a less than or a greater than, and we're looking for multiple rows. But for this, we're only looking for this one single row. And the problem is, when we then cross-reference that and get our number, this isn't for x equals 2. So let's write down what it actually is. This is for probability of x being less than or equal to 2. Because again, this is using cumulative frequency, and every number is a less than or equal number. So when x is at 2, that's less than or equal to 2. So how do we get x being exactly 2? Well, what we're going to have to do is take away things that we don't want. We don't want x equals 1, and we don't want x equals 0. So these need taken away. And we have the values for these. We have to look at the last one, because again, the x equals 0 figure is included in the x equals 1, because it's cumulative frequency. So we can say, well, the probability of x being less than or equal to 1 is given as 0.3191. And if we take these away from each other now, it's going to give us what we want. Because if you take away from all the numbers less than 2, all the numbers less than 1, you're taking away the 1 and the 0. So this will give us the probability of x being equal to 2. Type the two numbers into calculator, 0.6471, take away 0.3191, and that gives us 0.3280. So if you want exactly a number, because the tables are cumulative, you need to take away all the numbers below it. So let's look at another example like that. So we have n is equal to 8, p is equal to 0.35, and we're looking for when x is exactly equal to 3. So if we cross-reference that, we're going to get this number, 0.7064, but remember what we've actually found there is the probability of x being less than or equal to 3, which is 0.7064. So what we want to do is we want x to be exactly equal to 3. So we want to get rid of the 2 and the 1 and the 0 that's part of the number. So we look at the 1 to the left one of those numbers, the 2, 0.4278. That includes the x equals 0 and 1 numbers, and includes the x equals 2 number. So we take that away, we're going to take away 1 and 0 as well. So we've got a probability of x being less than or equal to 2 there, which is 0.4278. So if we take those away from each other, then what we're going to be left with is a probability of x being exactly equal to 3. So we type those numbers into a calculator, 0.7064, take away 0.4278, and that gives us 0.2786. So we found the probability of x being exactly equal to 3. For the next table, we find the correct table as normal, so n equals 7, and we can find a probability, this time it's 0.5. But something a little bit different with what we're looking for. We're looking for the probability of x not being equal to 2. So let's look at everything that's not equal to 2. So we want the 0 and the 1. They're not equal to 2. But we also want the 3, the 4, the 5, and the 6. These are also not equal to 2. So how are we going to do this? Well, we might be thinking about, find a way to find, well, we can find less than or equal to 1. And maybe we can find less than or equal to 6 and take some things away from that. That'd be quite complicated. Now, the fastest way to do this is find x is exactly equal to 2, which we've just been doing, and then take the answer away from 1. And to do that, we're going to want the number that corresponds to 0.5, and we're going to take away the number beneath it. Because again, when we look at x equals 2, that's actually the x is less than or equal to 2. So let's write this down. Probability of x being less than or equal to 2, 0.2266. The probability of x being less than or equal to 1 is 0.0625. So if we take these away from each other, we're going to get the probability of x being exactly equal to 2. So we type into our calculator 0.2266. We take away 0.0625, and it gives us 0.1641. So that's x being exactly equal to 2. So now we want to find the probability of x not being equal to 2. So the equal sign with a slash through it, that means not equal. And so all we need to do is take our answer away from 1, and you should get 0.8359. So yeah, a big thing with these are, trying to find what you're trying to find can be harder than finding the opposite of what you're trying to find and then taking it away from 1. So yes, you could find x is less than or equal to 1 and less than or equal to 6 and then take some things away from that. But it might just be easier to find what you don't want and take it away from 1. As usual for the next question, we find the correct table, so n is 5, and we find the correct column, so 0.45, the probability. And then we look at what the question is giving us. So for this one, well, the probability that x is less than or equal to 2, and we're going to have the probability that x is greater than or equal to 5. So we just need to highlight those in our table. So being less than or equal to 2, that's going to include 0, 1, and 2. Then being greater than or equal to 5, that's going to be everything above 5. And we don't have that in the table. So we can do this in two parts. So first, the probability of x being less than or equal to 2 is going to be pretty easy to find. You can get it directly from the table, and it is 0.5931. Now, what about the probability of x being greater than or equal to 5. Well, this will be the case. We can find something that we don't want and then take it away from 1. So what we could do, because 5 is not in the table, it's not in the table, it's going to give us 1. And so what we need to do is say, well, the probability of x being less than or equal to 5 is going to be equal to 1. Every single possible result is covered by that. Now, it won't actually be greater than or equal to 5. There's nothing greater than 5 in the table. We can have 6 or 7 or 8. We don't need to worry about that. We want to keep x equal to 5 because it's greater than or equal to 5. So what we don't want is 4, 3, 2, and 1. So let's take those away. So x being less than or equal to 4 is going to be 0.9815. And if we take these away from each other, then we get the probability of x being equal to 5, which for the purposes of this question is the same as greater than or equal. Because again, there is no 6, 7, 8 or 9. It can't be greater than in this question. So one takeaway, 0.9815, gives us 0.0185. So all we need to do now is add these two results together. And that's going to give us the probability of x being less than or equal to 2. And, or rather maybe we could say or here, because we don't mind which one it is. So we're going to add our answer onto 0.5931, and altogether that's going to give us 0.6116. Our next question is another combined question. So we've got table 20 and probability 0.2. And again, we want two things. We want less than or equal to 5 and greater than or equal to 14. So let's highlight the different possibilities. So firstly, less than or equal to 5. Well, 0, 1, 2, 3, 4, and 5 will satisfy that condition. And then greater than or equal to 14. So 14 all the way up to 20 is going to satisfy that condition. So we can do our calculation in two parts. So the probability of x being less than or equal to 5 is going to be equal to, let's see what it cross-references, it's going to be 0.8042. Next we want the greater than or equal to 14. So that's going to be quite tricky to find. What we could do is we could find the probability of x being less than or equal to 13, the number below it, and find all the things that we don't want. So let's cross-reference that number. It actually gives us 1 for this. So this is just basically telling us that it's so unlikely to get 12 in a row that 12 and above is going to be almost impossible to get. So we're saying by the time we get to x equals 12, then unless we're doing millions and millions of trials, we're not really going to get any values of x equals 12. If we just say flipping coins, we just wouldn't get 12 in a row. So this is going to be equal to 1. So that then means that the probability of x being greater than or equal to 14, we take that away from 1, and it is going to give us 0. So we can see the two numbers together add up to 1. So you might have examples where it isn't equal to 1 for the top one, and you get a different number for the bottom one. But for this case, x being greater than or equal to 14 just isn't going to happen. Not to 4 decimal places anyway. So for a final answer, we really should be adding on the x is greater than or equal to 14 and adding our two results together. But in this case, if one of them is equal to 0, then there's no point adding it on. It's not going to actually change the number. So we're just going to have the probability of x being less than or equal to 5, or x being greater than or equal to 14, just being equal to the 0.8042 that we started with our first answer. Now, for the hard questions, there are other things we can do with a binomial distribution. So firstly, a quick reminder. X follows a binomial distribution. 12 is n, which previously was the number a table would find to look at the value. And then the second number was p, the probability. So that would be the column we're looking at in the table. Now, there's some things we can do with these numbers. So, for example, we can find the mean. And a symbol for the mean is this letter, which is kind of the Greek symbol mu. And the mean is simply n multiplied by p. We can also find the variance, which is a measure of how far away from the mean most of the values are. The symbol for that is a sigma symbol with a squared symbol. We'll talk about why it's squared in a moment. And to find that, we multiply n by p, and then we multiply it by 1 minus p. The last thing we can find is the standard deviation. This is another measure of how far away from the mean most of the values are. The symbol for this is just a sigma. and it's not squared. So that means that we can take the same form of the variance, np 1 minus p, and we can square root it. So what is the question asking us? So we look at the question, it's saying find ux, find the mean of x. Looks like a u, it could be an m as well. So what do? So we just write down the mean is equal to n times p. So that's going to be n is 12, p is 0.1, so the mean is going to be 1.2. Now again, we should probably mention what this means. So let's say this is flipping coins. So we're flipping 12 coins, and we want to know what the average number of outcomes is going to be for, let's say, heads. And the probability for heads is 0.1. Well, with a 0.1 chance of heads, we flip 12 coins, we'd expect to get 1.2 heads. So we'd expect to get a little bit more than one head on average. So most of the time we get 1, sometimes we get 2, very rarely we get 0 or 3. And maybe you're really, really lucky, you might get 4, but you wouldn't really get anything outside of that. So let's look at another example. So firstly, label what you've got. We have n, which is 10. We have p, which is 0.15, and we're being asked to find the mean. So the mean is equal to n multiplied by p. So that's all we need to do. So the mean is equal to 10 multiplied by 0.15, which is going to give us 1.5. So again, if we were tossing 10 coins, the probability of getting heads was 0.15. Then we'd expect to get around about 1.5 heads. So we'd either get 1 or 2, and if we're lucky, we might get 0 or 3. So the mean's pretty easy, so let's have a go at finding the variance. So again, label your n and p. Look what you're trying to find. So again, in this case, we're looking for the variance, and write down the formula for the variance. So the variance is equal to n times p multiplied by 1 minus p. So do your substitution. So n is 25, we're multiplying that by 0.25. So that's the np part done. Then multiplying that by 1 minus p. So we can work out each bracket. So 25 times 0.25 is going to give us 6.25. Then we're multiplying that by 1, take away 0.25, which is 0.75. So we can do 6.25 multiplied by 0.75, and that gives us 4.6875. And then perhaps we're around it, so then we could write it 2 decimal places. I could say for our final answer, it's going to be 4.69. So let's have another go at finding the variance. So this time n is going to be equal to 6, and p is going to be equal to 0.3. We are finding the variance, and it's n times p multiplied by 1 minus p. So we can substitute 6 times 0.3 multiplied by 1 minus 0.3. And working this out on a calculator, that's going to give us 1.8 for the first bracket, multiplied by 0.7 for the second bracket. So we can put that into a calculator, 1.8 multiplied by 0.7, and we get 1.26. So hopefully seeing here that finding the variance isn't too difficult. It's just going to be a matter of remembering the formulas, remembering which number's n and which one's p. For our last question, we'll find the standard deviation. So n is 20 and p is 0.5. So to find the standard deviation, let's find the variance first. So np multiplied by 1 minus p. That's going to give us 20 multiplied by 0.5, which actually is just going to be 10. And that's going to be multiplied by 1 minus p, so 1 minus 0.5. And 1 minus 0.5 is just 0.5. So 10 times 0.5 will give us 5 altogether. So that's the variance, that's sigma squared. We've got the standard deviation, which is just sigma. Then that's going to be the square root of 5. And we can work out the square root of 5 in a calculator. It's going to be 2.2360679, and that's going to continue on. So what you could do is just round it. So for example, we could round it to 2 decimal places, and that would be 2.24 to 2 decimal places. The original number, the square root of 5, is an irrational number. So there's not going to be a pattern to that, and it's not going to, recur or anything like that. It's not going to stop. So the final answer is 2.24.
Ouch! This is why in some videos I'll explain scratches.